This is part 2 of section 5.2. We're now going to look at our cofunction identities. By definition, two trig functions f and g are called cofunctions if f of pi over 2 minus x is equal to g of x, and g of pi over 2 minus x is equal to f of x. So for example, if we write cosine of pi over 2 minus x, which would be the equivalent of one side of this, and we apply our subtraction formula, we get cosine of pi over 2 times cosine x plus sine of pi over 2 times sine x. Cosine of pi over 2 is 0, so that whole term goes away. Sine of pi over 2 is 1, so we simply get sine. And similarly, this works in reverse. My x here goes along with this. So if I take all of this and plug it in for x right here, I have this. Distribute the negative, your pi over 2's cancel out, and you get cosine of x. So sine and cosine are cofunctions, here and here. And with similar approaches, you can show that secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. Okay, so let's look at this, where we're asked to verify that tangent of pi over 2 minus v is equal to cotangent of v. Well, one thing I know about tangent is that I can rewrite it. My left-hand side is the same thing as sine of pi over 2 minus v over cosine of pi over 2 minus v. And that comes from the quotient identity. Now we can use our cofunctions here since we've already shown that sine and cosine are cofunctions. Sine of pi over 2 minus v is the same thing as cosine v. And cosine of pi over 2 minus v is equal to sine of v. And then one of our quotient identities is that cosine over sine is cotangent. So cotangent v, which is the right-hand side, and our identity has been proven. Okay, now we're going to show that secant and cosecant are identities, or cofunctions, sorry. My left-hand side is equal to, secant is 1 over cosine, so this is 1 over cosine of pi over 2 minus v. We know that cosine of pi over 2 minus v is sine of v, so this is 1 over sine of v. And one of our reciprocal identities is that 1 over sine is equal to cosecant. So this is cosecant v, which is the right-hand side, and the identity has been proven. Okay, now let's show that cosine of x minus pi over 2 is equal to sine of x. This is not quite in the right form for us to use our cofunction identities because it needs to be pi over 2 minus x. So my left-hand side is equal to cosine of. I really want to switch the order of subtraction here, so I'm going to factor out a negative to change that into pi over 2 minus x. Now we know that cosine is an even function, so that this negative gets absorbed, and this is exactly the same thing as cosine of pi over 2 minus x. And this is exactly our cofunction identity, so it is equal to sine of x. Okay. Now let's talk about the sum and difference formulas for sine and tangent. You can use the formulas, the addition and subtraction, sum and difference formulas for cosine and the cofunction identities to get these identities. I'm using the plus minus and minus plus again. If you have sine of u plus or minus v, sine mixes the cosine and sine. So you have sine of the first one times cosine of the second one, either plus or minus, and your signs are going to match here. Sine of your second times cosine of your first. Cosine does cosine, cosine, sine, sine, and the middle sign is opposite. Sine mixes cosine and sine, but you get to use the same symbol in the middle. Okay. For tangent, you get a fraction. Tangent of u plus or minus tangent of v, so you're going to use the same sign up here as you do here. But in the denominator, you're going to use the opposite sign. We have minus plus. 1 minus plus tangent of the first times tangent of the second. Okay, let's work some problems. Find the exact value of sine of 45 degrees minus 30 degrees. Well, this would be sine of 45 degrees times cosine of 30 degrees minus, we get to use the same sign. Now, sine of the other measure times cosine of the other measure. Okay? And sine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees is square root 3 over 2. Minus sine of 30 degrees is 1/2. Cosine of 45 degrees is square root 2 over 2. So we get the square root of 6 over 4 minus the square root of 2 over 4. So our answer, square root 6 minus square root 2 all over 4. Okay? So sine of 60 degrees plus 45 degrees. So this would be sine of 60 degrees times cosine of 45 degrees plus sine of 45 degrees times cosine of 60 degrees. Sine of 60 degrees is square root 3 over 2. Cosine of 45 is square root 2 over 2. Plus, this is square root 2 over 2 times 1/2. And you get square root 6 plus square root 2 over 4. I'm betting you don't need to see all of these steps written out anymore. Okay. Now let's do tangent of pi over 4 minus pi over 6. This would be equal to tangent of pi over 4. This is plus minus, this is plus minus, so we use the same sign, so it's going to be a minus tangent of the other measure, pi over 6, over 1. Here, this is minus plus. This was minus, so I use plus here. It's opposite sign. Tangent of pi over 4 times tangent of pi over 6. Okay? Tangent of pi over 4 is 1 minus tangent of pi over 6 is the square root of 3 over 3. Over 1 plus 1 times square root 3 over 3. Okay, so simplifying a little bit, not much here yet. Okay, Now what I'm going to do here is I'm going to multiply top and bottom by a 3 so I can get rid of these fractions. And that will give me 3 minus square root 3 over 3 plus square root 3. Now your book does rationalize this one. So multiply top and bottom by 3 minus square root 3. So you have a difference of squares in the bottom. And that gives you, this is squared, so that will be 9 minus 3 square root of 3 doubled, 6 square root 3 plus square root 3 squared is 3 over 3 squared, 9 minus 3. So that gives me 12 minus 6 square root 3 over 6, and that reduces to 2 minus the square root of 3.